A score tells you how well your model does. It doesn't tell you why it fails, or what to do about it. For that, you stop staring at the number and start looking at the mistakes themselves. This is error analysis, and it's where the biggest improvements usually come from. Say your churn model lands at 88% accuracy. It's tempting to stop here and celebrate. But hidden inside that number is a 12% it gets wrong. Those mistakes aren't random noise, they usually have a story. Our job is to go find that story. Start with the confusion matrix. It shows where the errors pile up. Here, almost all the mistakes sit in one cell. Customers who actually left, but the model predicted would stay. Those are the false negatives. So the model isn't failing everywhere. It is one specific blind spot. It misses people who are about to leave. Next, actually read the individual mistakes. Don't just count them. Look at them. Pull up the customers the model got wrong, one by one, and search for something they share. And a pattern jumps out. Nearly all of these missed customers are brand new. They signed up only a month or two ago. To confirm it, break the error rate down by group. Here's the mistake rate for each tenure band. Most groups are fine, under 10%. But look at the newest customers. The model gets a third of them wrong. That one red bar is dragging everything down. The overall score hit a serious weakness in one specific segment. Now the payoff. A diagnosis points to a fix. Because we know exactly where the model struggles, we know what to try. Maybe add a feature that captures early behavior. Maybe gather more examples of new customers. Or lower the decision threshold so the model flags them more readily. Each fix targets the real weakness, not a random guess. So, don't stop at the score. Read the confusion matrix, read the actual mistakes, and slice the errors by group to find where the model breaks. Then turn each pattern into a concrete fix. You now have the full reliable evaluation toolkit. In the final lesson, we put it all together to choose a model, without ever contaminating the test set.